This is the YOLO standard model from Coco dataset from the drone view, and it's terrible. It's not not detecting anything. One, for sure, for the reason that I explained you before, because in Coco dataset we don't have view from the drone. You need to train your model for these specific scenarios. It can detect some cars. You can see on the bottom left somehow it's working, but except that nothing good is happening here. Considering that detecting small objects with a high accuracy is a very common problem, some researchers created this algorithm SAHI, slicing aided hyperinference. As you see, here is a very clear explanation. It slices through the frames, it cuts the frame in many parts, and then we perform the detection on small chunks of the frame. And if we have a very big image, we can choose the size that we want of each rectangle that we want to perform the detection. This is very customizable, and the increase in the performance and accuracy, it's something extraordinary. Let's test this. SAHI is an algorithm that you find on GitHub, is MIT license. I'm going to put everything on the blog post. You'll check below all the references that I'm using. And then I'm going to load a custom implementation that I made of this one, and let's write that. Let's now make some small changes into the code to load this object detection with this algorithm. So from engine.sahi object detection, we're going to import SAHI object detection, and then let's load it. SAHI OD equals SAHI object detection. We choose the model. We load the same model, so it doesn't change. We load the same model. The only difference is that the model, instead of detecting everything on the entire image, is detecting piece by piece on that image. So model, we load again YOLO version 11 medium. It can be any model. Like the concept is that we're slicing through the window, so it doesn't change much with the model. These algorithms, I see it works with many different models. It works not only with YOLO, it works with Detector, and in the future, for sure, new model comes and it will be implemented also in that one. It's more about what is for and what it does. We now rewrite this part because it's slightly different. We get the predictions equals SAHI detect on the frame. That's pretty much what we have to do. And now we loop through the prediction for spread in predictions. We want a bounding box, from prediction bounding box. We want the class ID, and then we want the score. Three things. Location of the object, class, is that a person, is that a cat, whatever. The score, how confident we are about the accuracy. Let's test now this one. We want to now show the X, the bounding box. So we take X, Y, X2, Y2. And then let's draw a rectangle. So we do the rectangle on the frame. We draw the rectangle. And now let's run this one.